So guys, welcome to Math 1127. This time is session 7.2. One sample hypothesis test for mean. I forgot what the actual name of the session is, but it doesn't matter. The whole session is about doing the hypothesis test, this time only for one sample, meaning we're not comparing, say, Walmart to Costco. We'll just talk about Walmart, just one sample. And it's for the mean, the average. Now, this one is, of course, a more homework-based session. So I'm going to be mainly dealing with the homework problems. But I want to also talk about, just very briefly, right, just like the last time, what the hypothesis test supposed to be for this time. Now, the last time we already talked about that a hypothesis test should have first the null hypothesis versus the alternative hypothesis. Okay, that's cool. Then we also talk about how we can have the different type of test. So we have one. So we have to have one sample versus two sample. Now, right now we're talking one sample because we only have one thing, right? And we also should talk about what is it, a Z test or is it a T test? Now, here's a simple way to think about Z test. If sample size is bigger than or equal, let me find that symbol, bigger than or equal to 30. And if the population standard deviation is known. 9 times out of 10 it will be given to you in this class. In real life, however, that's usually not the case. But basically, you can think about if not, right? So if sample size is less than 30, then you can probably just use t-test. That's usually how it works now. Another one to look at would be whether or not it's a one tail. So I should look at this. One left one was one tail versus two tails. So what does that mean? Well, here. So if the null hypothesis, so kind of like this guy here, let's just say the mean is mu. Let's just say it's bigger than, let's just say 100 or something like that. This is what we call, oh, actually, my bad. Let's just say, remember, the null hypothesis has to be this guy. So let me just make sure. Symbol. Let's just say bigger than or equal to 100. And then the other guy, let's say this guy is mu less than 100. So remember, one has to be the opposite of the other. And in this case, this is going to be bigger than or equal to, and this is less than. So if the new hypothesis is greater than or equal to, and the alternative hypothesis is less than, right, like this, then this is a one tail and what we call specifically a left is a right tail test. And what is a right tail? If you have something less, oh, actually, my bad, less than, it's left tail, my fault. Left tail test, that's when it's less than something. If you're less than 100, you're to the left of 100, right? The farther left you go on a number line means you are less than, right? You're inferior. On the right hand side, you're bigger. So, left tail test, and I'll explain what those guys are in a little bit. B, if you have something like this, if the null hypothesis is less than or equal, and the alternative hypothesis is greater, that is, let me copy this right here. Let's say this guy is less than or equal to, and the other guy is bigger. Then this is a one tail, specifically a right tail test. For a simple reason that the alternative is bigger than 100, so it's on the right hand side. Now let's say if the null hypothesis is equal and the alternative hypothesis is not equal, that is, equal and the other guy is not equal, like this, then this is a two-tail test. There you go. Two-tail, because now you can be either on the left or on the right, right? When you're not equal to 100, you're either bigger than 100 or less than 100. So those are the three. So you can think about this way. When you have a test, when you have a hypothesis test, you have to think about a few different things. Three. When you conduct a hypothesis test, you have to consider the following. Is the test, are you testing for the mean, proportion, or standard deviation? B, are you testing for one sample or two samples? I would say you can do more than two samples. You can do 5, 6 different samples. That's called ANOVA, but that is beyond the scope of this class. Even though it's on your calculator, it's actually pretty simple. It's pretty much the same thing as two sample test. But let's do two sample first, and maybe we can talk about ANOVA. Now, you also got to think about is after you construct. Oh, actually, my bad. Is should you use a z-test or t-test. Then you gotta think about, hey, is this a left tail, right tail, or two-tail test? So those are the things you have to think about before you even start the problem. Now, I'm not very good at pictures, but I'm gonna try. Now again, this is on your PowerPoint presentation. They do a whole lot better job than me when it comes down to drawing these guys. So I'm gonna try to draw those tests. So the first one I'm gonna do is, let's see how to do it. I would do a left tail test. Okay, so that's the first one. And here's what it will look like. Be a line here. And let me try to draw this. It's gonna be ugly, so like this. I'm using my mouse right now. So you remember the normal distribution? That's basically what we're doing. So here's the deal. You're gonna be given something called level of significance. Think about this as, think of this as the level of reasonable doubt. So as we mentioned in in session 7.1, every test comes with a particular level of significance. What that means is, how difficult should it be for you to convict somebody of a crime that the prosecution is charging? How difficult should we convict or prove that the null hypothesis is guilty, right? So that is the how rigid or how difficult should it be to reject the null hypothesis. And the level of significance is usually, at least in this class, is called alpha. Okay. So sometimes you will see alpha equals 0.01, 0.05, and here's the deal. The larger alpha is, right, the larger it is, the more evidence or the more difficult it is for you to reject the null hypothesis. So of course, on the other side, the smaller alpha is, the less evidence or the easier it is for you to reject the null hypothesis. So you can think about another word. The bigger the alpha is, if alpha is big, the level of significance is big, then it favors the null. Whereas if it's a small alpha, then you favors the alternative hypothesis. And I'll explain in a little bit. So first I'm going to the paints. So here's the thing. So let's just say we have an alpha. Let's just say alpha. I'm just use A. The level of significance let's just say is alpha equals 0.05, which is a pretty popular way to do it. 0.05, what does that mean? That means you draw a picture. I'm going to use a different color right here. Say red. I'm going to draw a picture right here. So here's the deal right here. Right here at this point, right here. Oh, actually, my bad. We're doing left tail test, right? Let me erase this. Let's erase it right here. So basically, here's the deal. Right here. So again, this whole thing is a normal distribution. The whole thing is 100%, right? Basically, here's what we say. We're saying that right here on the left, I'm going to use blue color right here. This right here, right, is going to be zero. Change by the color. It's going to be 0.05. So right here. Well, you know what? Maybe it's easier if I just put that number in there. Hold on 1 second. Let me erase this. And you gotta excuse me because I'm not very good at doing this. Here you go. So draw this back here. So basically, right here. Is 0.05. Okay, so 5% of probability. So of course, then over this side would be 0.95, right? So basically, what we're saying is this: when you do the test later on, when you have your statistic, that's what we call the test statistic. Whatever number you get, we'll see if the number is going to be here on the left hand side or the right hand side. On the left hand side is what we call the rejection zone. Basically, reject the null hypothesis here. So if your statistic is on the left hand side right here, then you have to reject the null hypothesis. If it's on here, that's the acceptance zone. You can think about it this way. Now, let me go ahead and draw the other guys. So let's say you have a right tail. You can probably guess what it's going to look like. Right tail test. It'll look like this. It'll look like this. And on a right tail test, the right hand side is the rejection zone. Now, obviously, if we have a two tail test, here's a two tail test. It's gonna look like this. You're gonna get two, the left and the right. Now, here's the key. If you have two, right, let's say left of significant is 0.05. Here's the problem. You will have to split that alpha on the left and the right. So let me write this down. In a two-tailed test, you have to split the alpha by the level of significance in half. In our case, we will have 0.05 divided by 2, which is equal to 0.025. So what does that mean? That means on the left-hand side, you will get 0.025. And same thing over here. And it turns out, later on, when you put this in the calculator and you get your test statistic, if this guy is on the left right here, or the right over here, they will both be considered the rejection zone. So if you fall on the left, two fall on the left, two fall on the right, you will still reject the null hypothesis. So I'll just say this. Reject null here. Reject null here. So that's the kind of basic of this thing. Again, if this graph is confusing, just look at the PowerPoint and look at the test. Look at the video that I sent you on from the units from the learning unit from the actual lecture video. So now let me turn this back to the problem that we have. So let me say this. So let me talk about p-value. Right, sometimes we just call it p. What is p-value? Well, p-value is basically instead, so you will have, maybe I should talk about this guy in test statistics, which we usually call it t-stat or z-stat or t-stat. Those guys are basically the same thing. So p-value and the test statistics are the result you obtain from each hypothesis test, either by manual calculation or by using some sort of software or the calculator. Now, let's just say you get a t-stat of, say you get a z-stat, for example, of 2.65. Let's just say that's what you get. Then you can use that to find the corresponding p-value. Now, how do we do that? Let me use a calculator. So basically, turn this on. So basically, here's the idea. You would do second follows by distribution, just like what we did before. I am going to look at the normal, so I should, in TI 83 or 84. Use normal CDF. And then remember, for normal CDF, it's the lower bound, the upper bound, and then a mean and standard deviation. All you gotta do is put in negative 99999 actually my bad, 2.65, and then 99999, just like that. You can do 0.1 if you want to, but this is good enough. So let's say, just want to let you guys know you don't have to do this every time. Your calculator will do everything for you. I just try to explain to you what are the relationship between those two things. That's it. It turns out the p-value is 0.004. So you're like, well, what does that mean? Here, let me put this in the picture. So let's just say our test statistic. Say our z test statistic is 2.65. We found that the p-value is 0.004. Right. So that's what we got from here. So here's the deal. The z-test statistic would be somewhere about, so the p-value 0.004, right? That's the, so that, and also let's just say this is the, also let's say we have a, let's just say a right tail test. Right. So let's say it's this guy right here. So z statistic stat and p-value 0.04. Think about this, right? Remember we said this guy right here, alpha equals to 0.05, right? So if this whole thing is 0.05, 0.004, that's a very small number. That is like right here. So let me draw another line right here, just like that. So here's what we find. We find that this guy, 0.004, I should call it P as well. P equals 0.04. So what does that mean? My statistic, or that p-value, lands on the right of this line. So that means I am in the rejection zone. All right, so let me write this down. Since, oh, well, you know, this is good. Since the p-value is smaller than the level significant, right? Smaller than A, the level of significance, we will, the test statistic is thus fall into the rejection zone. That means we have enough evidence to reject the null hypothesis, right? Which is HO, right? So if your p-value is, say, 0.07, you might be all the way down here, right? Or maybe your p-value is all the way on the left, if it's in the safe zone. So you can think about, this is the rejection zone. This is the safe zone. You can think about it. So if you're in the safe zone, that means you're not guilty. That means your null hypothesis is good to go. You would accept that, or at least you fail to reject that because you assume that's true, right, by default. But if it's in here, that's when you're guilty. That means that null hypothesis is now convicted. So now you can think about it this way. Let me write this down here. That might help you. So how should we use the p-value? Here is a shortcut. I know you guys like shortcuts and all that. So here's the deal. If p-value is, well, actually, if we have a one-tail test, if the p-value is less than the level of significance, then we will, then there are enough evidence to reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. If we have a two-tailed test, if the p-value is less than half, remember you gotta cut it in half, there was significance, then there are enough. Was it there? There are enough evidence to reject the null hypothesis. Otherwise, we fail to reject. So let me clean up the grammar here a little bit. Look at that. So let me just draw a table up for you guys, and you can probably use that for like your tests and all that, and probably the final exam, since chances are we're not gonna be able to go back to campus this semester. So let's say p-value. Let me see. We can do like this: one tail, two tail. So like that. So this is like a one tail test. And let's say p is less than alpha. No one used the alpha thing. Let's say p less than alpha. And then this is p bigger than alpha. Then you can say conclusion. We reject. Reject the null hypothesis. There you go. If not, then we will fail to reject the null hypothesis. I like to make it all center, just like that. Okay. So now, if it's two tail. Let's do the same thing. This time would be two tail. All I gotta do is copy this, I guess. There you go. Two tail. So this will be over 2, right? Be over 2. So if you use this, you can always make the right conclusion. Say your calculator does not tell you that. Your calculator will give you your p-value. They will give you a test statistic. It's not going to give you the other stuff. You will have to decide whether or not it's correct. So I'm going to put this on the side right now because I want to show you guys how to do this on the calculator with some of the problems that we have. So let me see. Here's some examples. So example A would be, let me see. Let me just try to do this and this. So example A. Now, on the left-hand side, you see the example. We are going to do, you know how they try to save space and time on all this? They want you to deal with level significance, 0.01 first, and then do the second one. So we're going to ignore this for now. So usually, here's how I do it. The first example, right? We have level of significance, which is the alpha. which is the alpha, equals 0.01. I usually type this in first or write it down somewhere. And then what else I got? Then I have the null hypothesis. Try to get everything lined up. So like this, and there'll be honestly, if you're doing this on paper, it's a lot faster that way. Equals 134. Equals 134. All right, and then alternative hypothesis. Oh, this thing won't upload. Let me just put on the far right. Okay, and this time, let me see. It's gonna be mu not equals like this 134. All right, so this is basically given the information they gave us here. Now, they did not give us all any of the data, any of the information, because they basically give us the answer already. So this time they already know. So the conclusion is, so the test, you can say the test, the p value is 0, p equals 0.0156. So now, what conclusion should we make from this? Since, so in conclusion, since our p-value, this is a two-tailed test, right? So I should say right here, this is a two-tailed test. In conclusion, right, so we have to have an alpha. That means 0.005. In conclusion, here's the deal. P is 0.01. That is actually 0.01256. This guy is actually bigger, not just than alpha, but alpha over 2, right? So since P is bigger than alpha over 2, then alpha over 2, and this, right, because this is a two-tailed test, right? It's bigger than alpha over 2. We failed to reject the null hypothesis. Now, let's look at the answers over here, the choices. Do you reject or fail to reject? We fail to reject. So there's two ends over here. I fail to reject. And that's because P, the P value, is bigger. Where's the name? Bigger. Right, bigger than let me see. Like this. Yeah, I do have a question about this. I think the software might be wrong because since it's a two-tailed test, this guy should be divided by 2. But whatever. It doesn't matter. Either way, this p-value is bigger than neither one of those two, so it doesn't really matter. Do you reject or fail 0.02? Well, here's the thing. If we change the alpha to 0.02, right? Which is what they want here. P is less than 0.02. So based on their logic over here on the left, we'll definitely P is less than 0.02, right? And based on this, we'll have to reject the null hypothesis. Right. And don't ask me why it's not over 2. It should be over 2. I'm not sure why this is not happening. But when we do the other problem, we will see. But in other words, right now, P is less than 0.02. And based on this table right here, if it's less than alpha, you absolutely reject the null hypothesis. So we'll reject the null hypothesis because P is less than 0.02. And that's a done deal. So if you go by this table, you're always going to get it right. So now let's look at another example. So another example. This is, or you know, maybe it's easier if I do like this. Right, so this is like the problem that we are doing. 7.2.3. I got it from here. So let's look at 7.2.5. So this time we have, let's see, level significance and all this. So we got to do it 3 times. 0.01, 0.05, 0.10. So think about this, right? First, our p-value, right, is 0.0176. So for the first one, it's actually pretty easy. P is bigger than alpha, right? P is bigger than alpha. Therefore, you know what? I just like the other. I like this guy, alpha. Therefore, based on this table, if it's bigger than alpha, we fail to reject the null hypothesis. Like that. So we fail to reject because it's greater. Yep. Just like that. 0.05. Now it's less. So B. P is less than this guy. Therefore, we reject the null hypothesis. It's that easy. We reject because it's less. Alright. Now I'll let you guys do the third one. It's the same thing. So now let's look at another example. Find a p-value for the left tail hypothesis test with a test statistic of this guy. So what are they saying? Here's what they say. So example 7.2.9. Given the test statistic of z equals negative 1.32, what is the p-value? Well, this one's not bad because all you gotta do is use a calculator. And again, it's normal. So let me draw the picture really quickly. I wonder if I can do a new picture. Here you go, a new picture. I'm gonna save this so I can send it to you guys. So unit is 7.2. Guess I said picture 1. So here's the second one. Now, let me draw a bigger picture this time. Like this. And let me draw the, let me make it a little bit bigger. That might help. So like this. So this is the normal distribution thing. So if you go back to the problem, it says this: the level of significance, which is alpha, equals, let's say also what's 0.10. 0.10. And let's go ahead and get the other stuff too. So the test statistic, which is z equals negative 1.32. So first we have to two questions really. Find the p-value, and then we have to conclude whether or not to reject the null hypothesis. So the first thing to understand is that test statistics. So let's do the rejection zone first, right? So first of all, we have a left tail test. So that's from the problem. We have a left tailed test. So it's gonna be like this when we draw the picture. Like, so I'm gonna use blue. So it'll be like this. And basically we're saying on the left here, alpha equals 0.10. Okay. That means 10% of stuff is here. 90% is on the right. Right. This is the rejection zone again, right? So maybe I should say that. This is the rejection zone. If the test statistic is here, then reject the null hypothesis. So that's the whole idea on the left-hand side. So let's look at this. Test statistic is negative 1.32. The problem is, what is the p-value? Well, you can actually use a calculator to figure this out. So use a calculator. Here's what you got to do. You have to go to second, false, normal CDF. So this time, negative 1.32, you're on the left-hand side. So you are going from the left, right? So you're going from negative 999,999, comma, and then negative 1.32 to figure out what the number is. So you cannot do negative 1.32 and then positive 99999 because this is not a right tail test. This is left tail. You're looking for the stuff on the left. And if you go from the far left, you start at negative 999. So we got our p-value. Our p-value is 0.09. But let me see how many times they want us to round it. 4 decimal places. So this is going to be 0.093. 4. Right, so 0.934. There you go. Very nice. Then look at this. Let's go back down here. 0.934. So we just find out that the p-value equals P equals 0.0934, just like that. So should it be on the left-hand side of this blue line or on the right-hand side? P is less than A, less than alpha. this guy's less than 0.1. So therefore, let me draw a second line. You're like right here. You're like right up here. And this is the p-value. So let me write it in. P equals 0.0934. So not quite. So really close. And then the test statistic is going to be right here. Z equals negative 1.32. So basically your Z is right up here. So not yet, right? So let's say you have a negative, so not yet on the safe zone, right? Let's say you have a negative, probably -1, for example, and you're up here, then it's a lot better, right? Then you're in the safe zone, right? This is the safe zone. I should say that here. Save. Let me use green. So this is the safe zone. If the test statistic is here, then fail to reject the null hypothesis. Right. So we're not there in the safety. You say this guy right here is on the left in the rejection zone. P is less than A. Now, if you go back to the Word document right here, if you go back to the table, it says this right. One-tailed test. If your P is less than A, then you reject the null hypothesis. So you don't have to draw the picture, but the picture kind of explains to you, right, why it's rejected. So the P value is 0.0934. Since P is less than the alpha, okay, I need to do this. We conclude that we reject the null hypothesis. So let's go back to the question. Since P is less than, we will reject like that. And so now this time is found a p-value for this guy. So we have to see, we have the test statistic again, right? We got to find a p-value. It's the same thing. So let me just kind of work on it real quick. So go back to the calculator, right? And turn this back on. So here's the deal. We have try to make this a little bit bigger. So this guy is a right tail test. If it's right tail, then we cannot use this anymore. It's going to be on the right hand side, right? So this time it's not going to be, it's going to be normal CDF. So, but it's normal CDF, but it's going to be the Z statistic first. So there'll be 1.33, comma, then 99999, because we're looking for the right hand side. So let's look at the p-value. It's 0. Run to 4 decimal places. 0.0918. And again, I want to let you guys know, once we do the whole hypothesis testing, once we start doing the actual problem, you don't have to deal with this anymore because your calculator will give you the answer. Right now, we're just trying to understand what's going on here. So we got it. State your conclusion. Your p-value is way bigger than your alpha. And remember, right, go back to the table. It says if it's bigger, then you fail to reject. So there you go. Now let's say this is two-tail. So now we can see what's going on with that. So we got the test statistic, negative 2.24. Let's try that again. Now, since this guy's negative 2.24, we are now talking about on the left-hand side. right? Because it's negative. So if it's on the left-hand side, you got to start out with negative 999,999. So I guess you can think about it this way. If your statistic is negative, then you can go with the negative first. Otherwise, it's going to be the positive side. So negative 2.24. Your p-value is now 0.0125. Wait a minute. 0.0. How many decimal do you want? 4 decimal places. Two tail. 125. Let me see. I'm gonna get this wrong. See, probably something stupid. Let me see. 2.0251. Let me check this. I'm gonna try the other way and say negative 2.24, comma. I don't believe that will be correct. No, that's not correct. So let me see. Well, that is strange. True tail test. Oh, you know what? I think I realized something. So here's what they did in the. That's what's different between this, the way they do it and the way I do it is, instead of divide by alpha, they multiply the p-value. So you can change this here. If it's a two-tail test, multiply the p by 2 instead of dividing. Now, if you've done algebra, you understand that it doesn't really matter, right? You can multiply by this by 2. That's the same thing as dividing the other side by 2. So like that. Okay, so that's my fault. I should look at that before I do it. But I always go by divide by 2, but they do the other side. So basically, that's the p-value. So if you have a two-tail test, just multiply it by 2. So like this. So you now get the answer. Right. So on the final, if you made that mistake, I'm not gonna take any points off since I messed this one up too. So that's my fault. So the p-value just multiply by 2 if you have a two-tail test. So let me say this then. I'm gonna change this right here. So when you see it, you can use it. The level of significance, if it's two-tail, if twice is less than the level of significance. Like that. So that will fix it. Okay. So now, what's the conclusion? Your p-value is 0.0251. That is still less than alpha, right? So if it's less than alpha, again, look at this. Less than alpha, reject it now. So that part's easy. Now, we are starting to get into a more of a real problem. We haven't got there yet, but it's getting to something that would be more likely that you will see if you ever work in statistics or for an employer who would like to produce a stat report. So the first one here, example. This is 7.2.28 t. So they already gave you the claim. So I always just kind of write down the problem again, just because that will help me. So first we are claiming that the mean is bigger, right? Bigger than 1230. So let me just go ahead and create this real fast. The A, we can say that the null hypothesis which is this, and then the alternative hypothesis. This. So look at this, right? They say the claim is the mean bigger than 1230. So that should belong to the bottom, because remember, if it doesn't have an equal sign, then it's at the bottom. Then it's an alternative. It's just this guy is supposed to be the claim. Now let's go up here to the null hypothesis. That's the opposite to this thing. So now you get this guy less than or equal to, which is the opposite, right? 1230. Right. I don't like this guy, right? Let me just. All right. So now, what else do we know? Level of significance. Level of significance, which is alpha, equals what is it? 0.02. Now we know a little bit more than that, because we know that based on, so now this time they give you the data summaries, right? Because they're telling you the standard deviation, the mean, and the sample size. So let me just type it down first. So sample size n equals 200. Then what else do we know? The mean, right? Which is the over bar x. Let me see how I can do that. This is usually how I do it. Oh, correct. Mean. Should have found like a hat. Okay. All right, found it. So over bar right here. That's the mean. So this is a sample mean, right? I should be more specific. So those who did not forget how to do this, right? This is a sample mean. The mu, right? This guy is the population mean. This is a sample mean. This is the mean for everybody. This is the mean based on the information, the data that you collected, or somebody, in this case, somebody gave that to you. And the sample mean is 56.49. Let's see. The standard deviation. In this case, we know the true standard deviation, which is that's the thing right here, equals 214.17. All right. So I usually write it all down just so I know ahead of time. Of course, it takes a little bit more time here, but this data summary. So here's the situation. Somebody is making this claim that the mean is bigger than 1230. You want to see whether or not that claim is supported by evidence. So you got the data summary. This is somebody collected 200 samples to kind of test what's going on. And the mean based on those 200 samples, it could be like SAT score or something. So it's 1256.49. That's the mean, and that's the standard deviation. The question is, look at this, right? Isn't this a little bit bigger than 1230? Right? A little bit bigger. The question is this enough? Is this evidence enough to kind of say, hey, the mean is indeed bigger than 1230, right? Because the mean here is bigger, the sample mean is bigger. The question is, what about the whole population? So basically, you're using that 200 sample just to see if that is enough collection and enough statistic that you got from those 200, right, to prove with this reasonable doubt, 0.02, that indeed the claim is correct. The claim is believable. That is bigger than 1230. So now, let me go ahead and, so the question is, how do you get, so the results, obtain the test statistic and p-value. So it turns out this is the easiest part of the game. So test statistic. So first of all, we will have to use, this is a one-tail test, and it's a right tail. Use one sample test, mean test. Right. So one sample hypothesis test for mean. Right. This one is going to be a right tail test. And we are going to be using Z test. Why is it Z test? Because it's bigger. The sample size is bigger than 30, right? And we know the standard deviation for the population. So we know that. And we are going to go to our calculator, which is a good thing. Oh, some go wrong. Let me move this. All right. So let me turn this on. Now, this is where the magic happens. Because it turns out your calculator will do everything for you. All you need to do is go to stat, test, you see Z test? Z test is basically one sample mean test and using Z distribution, the standard distribution, right? The normal distribution. Enter, right? Now, in here, you're not going to use data. You're going to use stat. Why do we use stat? Because data would be if you have 200 of those data listed on an Excel file or something like that. You don't have that. You have the stat. They gave you the summaries. So this is the summaries. So what do we have? First, we have to give them the mu. It's 1230. What's the standard deviation? 214.17. What's the mean? The sample mean is 1256.49. And what's the end? The sample size 200. Nice, right? And now, what's this guy on the bottom? That is the alternative. You see how there's no equal sign here? Alternative hypothesis is bigger than, right? So you go to bigger. Right here. Hit enter. Just like that. And all you have to do, man, is hit calculate. Look at that. Now you have the using TI-8384. We find that the test statistic, Z equals 1.7492. And we also found the p-value, and that's why I say we don't have to worry about the p-value so much. They give that to us right here. P-value is 0.0401. Okay, so that's pretty easy. They give us all the information already. So now we got the p-value, we got all this other stuff. So how does that help us? Conclusion. Since p, look at the p. P is bigger than alpha in this case, right? See that? Since p is bigger than alpha, the level of significance. And based on what we said before with this table, if p is bigger than alpha, then we fail to reject the null hypothesis. There is not enough, or there are not enough evidence to reject the null hypothesis. Therefore, we will still accept it. Right? Or you can say it is still assumed to be true. But what does that? So that means this guy is clear, right? This guy's been found not guilty. If this guy's found not guilty, that means he's innocent, right? I mean, at least presumed to be innocent, right? So the alternative, which means he's guilty, that is off the table. The claim is the alternative. So that means the claim is not supported by evidence. So now let's go back to the problem. So first, see, I like to do all this first before I even answer those questions because I don't want to get misled. So first, right, let's look at the test. I have less than equal to and greater than, so that should be this one. Hold on a second. Less than equal to, oh, it should be 1230, right? My bad. Right here. That's it. Okay. Now let's see. The standardized test statistic, which is this guy right here. The Z test statistic is 1.74, which is 1.75, basically. They want 2 decimal places. So got that. And what's the p-value? Here's the p-value. 0.3 decimal places. So it'll be like this. 0, right? I mean, 0.04. Done. Determine the outcome. So we say we fail to reject at 2% significant level. That is not enough evidence to support the claim, because the claim is the alternative, right? You cannot support it because you're not rejecting it, you're just not supporting it. Remember, rejection comes from the null hypothesis, right? Alternative, we just say there's not enough support. And this stuff. It is pretty tough. The map is not tough, it's just a lot of steps, right? So let's go ahead and do another one. So this time, I'm gonna see if we can pick up the pace here. I know I've been wasting your time. So 7.2.30 T. Let's see. So what I would do is I'm going to go ahead and copy all of this, because what will happen is we're going to be using most of these guys anyway. So And I'll just go ahead and delete all this. All right. So let's see. So this time we have, let me just go ahead to the second page. There you go. So let's see. First, we have the claim is the mean is less than or equal to 1180. So this guy should be, how come it's not letting me go down there? There you go. So less than or equal, right, less than or equal to 1180, right, and that is the claim, right there, right, and that's just from here. If that's less than or equal to, right, the null hypothesis, the other guy must be the opposite, which is bigger, just like that, right? The level significance is 0.07. Let's look at the sample size. Sample size is 250. Again, I'm just getting from the problem. The sample mean is 1209.56, and the standard deviation is 198.65. And this time, right, let's see, what kind of test do we have? First of all, this is a right tail test. Right, right tail test, right, just like before, because it's bigger than. Right, and it's for the mean. Right? The whole session is for about the mean, and there's a z-test because the sample size is bigger than 30, and we know the standard deviation for the population. So let's go ahead and put this in the calculator. So in the calculator, let me see. I'll go to stat, test, right, z-test. Same thing. I'll just go ahead and change the numbers. So we have the mean is 1180. This, and then the standard deviation is 198.65. The mean is 1209.86, and the sample size is 250. And we have the same as right tail test. Calculate. See, pretty easy, right? 2.3767. Right. Well, they want two decimal places, so let's do two decimal places. So 2.38. P-value is 0.009, three decimal places. And I'm not going to delete this yet. I'm just going to go to the answer here. So now, the conclusion would be this. The p-value is slightly bigger than alpha, right? So since p is bigger than alpha, and remember, again, you can scroll up every time. P less than alpha reject, P bigger than alpha fail to reject. We will once again fail to reject the null hypothesis. The null hypothesis. Therefore, there is not enough evidence to reject the claim, right? Because remember, the claim is the null hypothesis, right? So let's see if we can answer these questions. First, mu is less than or equal to this one. Yep. And then we have the standardized test statistic, which is 2.38. 2.38. P-value is 0.009. There you go. And then let's see. So we will fail to reject null hypothesis because there is, because the P is bigger than A, and then at this level, there is not enough evidence to reject the claim. Oh, you know what? I think I should say it like this. There is enough Hold on a second. What was the claim again? The claim was less than, right? You failed to reject. Alpha is bigger, so fail to reject this. What's going on here? Let me go back. Reject, no. Fail to reject. Let me see what I did wrong here. Let me go back. So, oh, here's my fault. My bad, I'm tripping, because I have 0.009, right? And this is 0.07, right? Of course. I was thinking this is 0.09. My bad. This is small. This is less than, so therefore we absolutely should reject my fault. I don't know what's going on with me. So p-value 0.009, which is less than this guy, right? I thought it was 0.09 for some reason. So therefore, there is actually enough evidence to reject the claim. My bad, guys. Messed that up. So that's that, though. So you see, it's the same thing every single problem. Let me go to the next one and say, this one's almost the same thing. So simple 90 people claim. So you just got to look at number 12 here. Example. And this one is 7.2.33t. So first, so I'm gonna do the same thing as before, just copy everything over. So this time we have a nutritionist saying that the mean, so the claim is, the mean tuna consumption by a person is 3.9 pounds per year. The sample of 90, so let's just go by let's digest the first sentences first, right? They're claiming that that per year we will consume 3.9 pounds of tuna. So this is a problem of equal. Because they didn't say bigger than or less than or not like that, right? You just say the consumption is 3.9. So this is equal 3.9. So if you go down, you can find not equal. And that will be 3.9 as well, right? Except the claim is on the top. Just like that. And the alpha is 0.09. So let's look at this. Sample size is 90 because they basically got 90 people. And check out how much tuna they got. The mean is 1 point. Right, so I'm sorry, 3.5. And the standard deviation is 1.24. You say it's the same thing, you just got to fill in the blank. You're more than welcome to use this to do your homework, of course. And then use one sample hypothesis test for mean right tail test. Let me see. In this case, we have a one sample hypothesis test, but it's not going to be right tail. This time it's going to be two tail, because it's not equal, right? So using this guy, let's see if we can find it. Back to my calculator. This is the poor man's calculator, by the way. This is something I downloaded. So if you need one, just let me know. but it's better to have an actual calculator in hand. So stat, test. If you go to z-test, same thing. Let's check it out. 3.9, and this standard deviation is 1.24, and the mean is 3.5. Sample size is 90, and this is not equal, right? It's two-tailed, right? So calculate. So again, we have a. Let me delete this. The test statistic is negative 3.06, and the p-value is 0.002. So now let me just go ahead and answer this question real fast. It's so our alpha is 0.09. P is definitely less than this, right? So don't make the same mistake I made, but 0.009, 0.002 is less than 0.09. So since P is less than alpha, then we can say that you can again go back to the table, right? P less than alpha is reject, right? So we'll reject the null hypothesis. Now the problem is looking at this. That's the claim. That's the null hypothesis. So there is enough evidence to reject the claim because it was the null hypothesis. So let's see. So first, equal 3.9 and not equal. That's right here. The test statistics negative 3.06. Check. And the p-value is 0.002. Check. And then of course, in the end is we will have to reject the null hypothesis. And there's two of them. Reject, and there's sufficient evidence to reject the claim, right? Because the claim is the null hypothesis. Now look at this. There's not sufficient evidence to reject the claim, but this is wrong, right? So A is right. There you go. Now this one is a little bit harder because, and when I say hard, I just mean it's just new, right? So let's go ahead and get this done first. We're now at number 13. So this is example 7.2.35T. So I'll do the same thing. Go ahead and so that's what we got here. So first, look at all this data. Let's not worry about it right now. We're gonna put this on the calculator. So first, we have a random sample of 32 former smokers to quit smoking permanently. So that's 32, and assume the population standard deviation 6.7. You can go ahead and type this in. 6.7 is the standard deviation. At alpha equals 0.08. So you say, I'm just kind of reading the problem as I go. Is there enough evidence to reject the claim that the mean time to take the smokers to quit is 14 years? So the question is whether or not it will take 14 years. That's the average for smokers to quit. So that's kind of like the question we had before, where it's going to be equal 14. And the other guy, of course, is going to be not equal to 14. And which one's the claim? The top one. Because the claim is it will take 14 years. Now, we don't know these things right here. right? Because they gave us the data. Now, before you start taking your calculator and try to find the mean and all this, you don't have to do that because this time it's going to be data input. Right? We're going to do data input. Here's how we do it. We're going to use, so let's go to the calculator. This one's nice because I can go to, so this is important. Go to stat, edit, and I'm going to put all the numbers in the L1 column. You can put L2 if you want, it doesn't matter. But to make it easier for me, I just go up here and just type in 20.6, right? Comma. You can, you know what, I just do it the way you guys do. So you can go here and say 20.6 and hit enter, right? And then 16.6, you basically just put all the numbers, right, from here on the left. So 7.5. I have trouble reading this. Let me just click on this. Well, you know what? That's gonna do so 22.2. If you're using Excel, it's a little bit easier, but I suppose most of you guys are using calculators right now. So 7.2, 13.1, 12.8, 22.7, 7.8, 9.4, 22.4, 20.1, 12.5, 21.6, 20.3. Yeah, this one's definitely tough. There's a lot of lumber to put in. Later on, we're gonna be doing some with smaller numbers, you know, like with not as many sample size, and we'll be using t-test. The good thing is we'll have like 7 numbers to deal with. 17.6, 18.6, 21.8, 17.7, 11.6, 8.3, 9.7, 16.3, 20.9, 12.9, and 17.3. All right, finally. So now, what is the difference? So first, you got to hit second mode to go back to main window. So what you got to do is this. Go to stat. So again, z-test, right? Instead of stats, right? This is for the summaries that we've been doing before. We are going to do data. Okay, so maybe I should say data input, right? So first, the standard deviation is given to us, right? 6.7. That's from the problem. Oh, that's the mean, my bad. So I'm going to type that's 14, and then a standard deviation is 6.7. And this is L1 because I use L1 to do it. Now, if you did not use L1, if you use another number, here's what you gotta do. Clear this. Here's how you get. You see the L1 here in the yellow, L2, L3. You gotta do second. Say L2, right? But I use L1, so second one. It's L1. Frequency, you don't have to worry about that in this class. It's always gonna be 1. So now let's see. We have a 2-tailed test. So that's not equal. So let's calculate. So let's see. We got, let me type this down here. So the test statistic is 1.718. And the p-value is, let me say, 0.086. Okay, and remember, since we have a two-tailed test, p is now equal to, right, 2 times p equals to, what's that equal to? 0.086 times 2. That would be 0.172. Right? So now we gotta look at this number. This number, right? So now this guy, right, is, you know what? I just realized that in the last problem I forgot to do that. 2 times 2. My fault, my fault. So that should be 2, since we are doing the two-tailed test. 2 times p equals 2.004. Doesn't matter in the last problem since. So let's see, 2 times that is this. So how does that compare to our alpha? So this guy is definitely bigger, right? Either way, times 2 or not. So since p is bigger than alpha, we will have to, so look at the table again, right? It's bigger than alpha, will fail. We fail to reject the null hypothesis. Therefore, you can say this, that's the claim, right? The null hypothesis. So we do not have enough evidence to reject the claim. So now let's look at this. So first, the test is equal 14 or not equal 14, and that's the claim right here. Done. The statistic is 1.718. They want 2 decimal places, my bad. So 1.72. Let me change that. Check. And then the p value would be 0.1. They want 3 decimal places, so 0.172. Well, it's still not working. Let me see. I guess let me be more careful and just multiply this whole thing. So 0.0858629 times 2. 3 decimal places, right? This should be right. Well, I guess let me just put in the other one and say just 0.086. Just see if it works. Yep. I don't know what this thing. Look, man, Pearson is stupid because they want you to multiply by 2 after they put this in the answer. So you just got to give them what they want. So now, what do we know? We failed to reject the null hypothesis. So that's these two, right? There is enough evidence to reject. No, we don't have enough. We do not have enough evidence to reject the claim. That's what it says here. Done. And that is done. This session is the beginning of the actual hypothesis test. That's why it's taking a lot of time and I'm typing this up. But let me save this right here. I'm gonna save it. I'm gonna send it to you guys along with the video. So hopefully this can help out a little bit. All right. So I know it's tough, man. Just let me know. Just send me a question. Email to me if you want me to work on a particular problem. Just let me know. I can work it out, man. So stay safe, and I'll see you in the next video.